A very warm good morning to one and all present over here class. Welcome to the digital platform of APS. Now this is Pawan Kumar. Today I will discuss some questions or some theory related to three-dimensional geometry. So class C. Now in today's lecture I will discuss some questions related to vector equation of a line passing through given point and parallel to the given vector. So see, vector equation of a line passing through a given vector, a given point, passing through a given point and parallel to a given vector. Now this is the statement. You know, this is the statement. Vector equation of a line passing through a given point and parallel to the given vector. Now, suppose we are going to consider the vector equation of a straight line passing through a given fixed point. Consider vector equation of a line passing through a given point. Consider passing through a given point whose position vector suppose vector A and parallel to given vector B. So what will be the result and what will be the equation? This is vector R is equal to vector A plus lambda times vector B. Lambda times vector B, where lambda is any scalar. Where lambda is any scalar you can consider. Scalar quantity. Now see, suppose this is x-axis, this is z-axis, and this is positive y-axis. Now consider any point P. We are going to consider any point P. Or any point A whose position vector is with respect to origin is vector A, and we have to calculate the vector equation of a line which passes through this point. Now suppose this is the line L whose equation we have to calculate. Suppose this is the line, and this line means this line L1 is parallel to any line. Suppose this is L2. This line is parallel to any line L2. This is L2. Now you can suppose this is the point P whose position vector, suppose this is OP. This is OP means this is vector R having coordinates x, y, z. Now this is the vector equation of a line which passes through vector point A and parallel to vector B. Now I will change this. This is the vector equation. Now I will discuss Cartesian equation. Now see, now I will discuss Cartesian equation. Cartesian equation. Vector equation, you know. Vector equation of a line passing through a given point and parallel to given vector. Now how you will convert Cartesian equation? So since vector equation of a line, passing through a given vector or a given point, and parallel to given vector, and parallel to given vector. That is vector R is equal to vector A plus lambda vector B. you know. Now suppose you are going to convert in Cartesian format. So how you can write? Let r vector is equal to xi plus yj plus zk. Vector A is equal to, this is the passing points, so x1i plus y1j plus z1k. Suppose and B vector you can consider, what we can consider, B vector is given and a parallel vector, so you can suppose in terms of their directions cosines. So we can write vector B is equal to Li plus mj plus nk. Now all these value we have to put in this equation. So you will get xi plus yj plus zk is equal to x1i plus y1j plus z1k plus lambda times Li plus mj plus nk. Now from this equation, when you will simplify or when you will find lambda, so what you will get the result? See, when you will find the lambda, so what you will get the result? See, x minus x1 upon L is equal to y minus y1 upon m is equal to z minus z1 upon n, and this is equal to lambda. Now this is the Cartesian equation. This is the Cartesian equation of a line passing through a given point and a parallel to given vector, means the vector which is parallel, so it's a direction cosine I have to write in denominator. So this is the Cartesian equations. See, and this equation is also known as a parametric equation. See, now if any doubts can clear it. And lambda is equal to, you know, where lambda is equal to, we can write, where lambda is equal to, what will be the result? Lambda is equal to, we can write in under root whole part, in under root, this is x minus x1 whole square plus y minus y1 whole square plus z minus z1 whole square. This is x minus x1 whole square plus y minus y1 whole square plus z minus z1 whole square whole upon, this is root over L square plus m square plus n square, root over L square plus m square plus n square. Now see, if any doubts can clear it. Now I will come to the next heading. The next heading is Suppose you have a point, you can take example, fifth and sixth point is, now sixth point is vector and its negative vector makes an angle of 180 degree. So vector A multiply by negative of vector A. So what we can write? Vector A multiply by negative of vector A. Vector A multiply by negative of vector A. So what we can write? Mod of vector A into mod of minus vector A. So this one what we can write? This one we can write mod of vector A negative times mod of vector A, means negative we can take outside. So minus times we can write minus times mod of vector A whole square. This is A dot A minus times mod of vector A whole square. Pi is equal to negative sign. Now seventh point is for mutually perpendicular unit vectors. Unit vector you know, I, j, k. So you will see this is I vector in the direction of x axis, j vector in the direction of y axis, and k vector this is xyz axis, and this is vector k unit vector in the direction of z axis. So for mutually perpendicular unit vectors we have for mutually perpendicular vectors perpendicular unit vectors I, j, k, I, j, k, what we can write? I dot I, unit vector I dot product with I, result will be 0. Unit vector j with j, result will be 0. Unit vector k not 0, I dot j will be 0, I dot I result will be 1. So angle will be 0 degree, so this result will be 1. And now for perpendicular vectors, you know, in case of perpendicular means I dot j, what we can write? I dot j result we can write also I dot j result we can write 0. J dot k result will be 0, and k dot I result will be 0. K dot I, j dot k and k dot I result will be 0. See, now I will come to the next point. The next point is The next point is angle between two vectors, 8 point or 7 point. Angle between two vectors A and vector B can be calculated by using the formula. Can be calculate by using the formula, and formula is, cos theta is equal to vector A dot vector B whole upon vector A dot vector B, their modulus. So this is the formula. With the help of this formula we can calculate these angles. Now we can write theta is equal to cos inverse vector A dot vector B whole upon mod of vector A into mod of vector B. This is the formula. You can calculate easily angles. And next, in dot product, scalar product is commutative. 8th point is scalar product is commutative. So scalar product is commutative means what we can write? This implies vector A dot vector B is equal to vector B dot vector A. Both have the same result. Vector B dot vector A. So both will be same. B dot A dot B. Angle between two vectors will be same. If you will take this third vector C, suppose, so A dot B or B dot C or C dot A just will be the scalar. So expression, what we can write? Expression we can write the expression vector A dot B, this is the expression, and suppose when you will multiply A dot B, you will get a scalar, and you are going to multiply any other vector C. So when you will multiply with any other vector C or A dot B, suppose A dot B dot C or C dot A dot B. C dot A dot B has no meaning. Have no meaning. Have no meaning. Now see. Now this one is totally completed.